Unit 1, the alphabet and grammar of geometry. Lesson 1.4, brain in hand. Remember, as you're watching this video, to record the location, the date and time, and to get a parent, guardian, or teacher sign-off. Your review page. Do this without a calculator. Show your work in pencil, please. Pause. Welcome back. Now in red pen, I'd like you to correct your work. Let's check. You ask yourself, why did I write 6 times 9 versus 54? Well, there's a little trick here. You're going to hear me say this in class. The key to multiplying is not multiplying. It's factoring, especially when you're not using a calculator. Let me say that again. The key to multiplying is not multiplying. It's factoring. One more time, let me write it. The key to multiplying is not multiplying. It is factoring. This is the key to multiplying without a calculator. Let me show you what I mean. So notice I did not write 54 and 6 times 9. I just wrote 6 times 9. So over here, I'm going to get rid of this 2, divide both sides by 2. Over here, I just factor. 2 goes into 9 evenly 3 times. Therefore, x equals 27. When you're not using a calculator, the key to multiplying is not to actually multiply, but to factor things out. You'll see more of this as we continue our review. In solving multi-step problems, especially when you're dealing with distributive, I want you to grab and draw those distributive arrows. Notice I circle, grab and draw the distributive arrows. That keeps your eyeballs from not missing stuff. I rewrite it. I'm going to go 8, and this is minus 10v, double negative makes a positive, plus 12 equals negative 4v, double negative makes a positive, plus 32 minus 3v. I like to do physical collection, so on each side, I make some sort of notation on alike kinds. So negative 10v is by itself, and then 8 plus 12 is 20. Over here, I'm going to collect my v's, that's negative 7v. What's left is 32. I want to get my variables to one side, numbers to the other. So I'm going to add 10v both sides. Cross it out and cancel. Then minus 32 to the other side. Divide out that 3. 3 goes into 12 4 times, therefore, check your work. Now, using a red pen, I'd like you to correct your work. If it's correct, big star or smiley or some sort of, I'm such a wonderful math student. If it's incorrect, I expect you to correct your work and then write yourself a little note. What are you going to remember next time? What are you going to remember next time? This is probably going to be one of the most critical videos you watch this entire year. There's about 5 what I call critical videos, absolutely, utterly essential. What I'm going to be talking about also may sound a bit strange to you. Please be aware, as I am talking through this lesson, I did my master's degree in education, and my thesis, my master's thesis and project revolved around this concept. So I have done extensive research and experimentation with this particular concept. So as I ask you to do certain things and highlight a certain style of learning, be aware this is not just coming up from a whim or Miss Way's personality. It's actually based upon very extensive research and experimentation. So we're going to be talking about problem solving, everyone's favorite subject. By the time we're done with this lesson, you're going to be familiar with these words: neurons, frontal cortex, digital immigrant, digital native, hypertext skimming, and linear reading. Let me tell you, where did this lesson come from? Over many, many, many years of tutoring, I'd be with students individually, and I would write a geometry problem on the board, even if it's relatively simplistic, and then I'd have a student simply stare at the board, notice their hands not touching the board, not drawing, not underlining, not processing information, but they simply look at the problem, hands crossed, and I get some sort of look, I don't get it. And this would literally happen hundreds and hundreds and hundreds of times in tutoring. And to me as a teacher, in my mind, this seemed like a really easy problem. And in my students' mind that I was tutoring, it seemed so difficult. So what made a problem easy for me and hard for my student? It was not simply that I was the teacher and this was the student. It had to deal with the way we processed information. My brain was working very differently than my student's brain in the how we processed information. And it has a lot to do with the fact that I, as your teacher, I am what's called a digital immigrant. I don't need to tell you my exact age, but let's say, suffice to say, I did not grow up with internet technology as a child. You, as my students, however, are what are called digital natives. Obviously, you grew up with digital technology and iPhones and iPads and computers and everything from the moment you were born. That means our brains are wired very differently. And there's 5 key thoughts you need to understand on what makes our brains different and how you need to modify how you process information to process it effectively. And the first thing you need to understand is that your fingers are actually connected to what's called your frontal cortex. My original degree, I have a master's degree, in education, but my bachelor's degree is in occupational therapy. It's a rehab degree. Therefore, I have studied neurology as part of my rehab degree. That neurology is the study of the brain. And your fingertips, the nerves from your fingertips directly connect to what's called the frontal cortex. The frontal means front, cortex means the outer part of your brain, and this frontal cortex processes information as you receive through your fingertips. Now, if this sounds a little strange, please, you and your parents are welcome. I have every single one of these key thoughts footnoted. You're welcome to click or look up these footnotes so that you know I'm not totally crazy right now. But the nerve endings on your fingers help you process information and the frontal cortex of your brain. That is the conscious thinking part of your brain. We process information through our fingertips. Why is that a key thought? Well, very simple. When you're working on a geometry problem, if your fingers are not drawing, tracing, shading, underlining, writing down the work, if you are not actively interacting with the information in your diagrams and the text with your hands, you are not thinking fully and properly. You are not activating your frontal cortex. In other words, your brain does not simply process information through your eyeballs. Although, because you are digital natives, that is the predominant way you tend to process information. Your brain processes information through your fingertips. In fact, in geometry, processing information physically through your fingertips is even more important than simply looking at information through your eyeballs. That's key thought number one. Key thought number two, and once again, this is based on research. You can specifically look this up from a book called iBrain. And you need to understand that technology is reshaping how our brains are physically wired. Why is that? When we keyboard more than we write, physically write, I'm going to be emphasizing physically writing more than keyboarding. When we keyboard more than we write, when we click more than we physically color, when we tap on screens versus physically touch models, all of this is causing our brains to wire differently. And I make the premise that if you are not physically interacting with your world by doing things like physically writing things out, coloring, drawing, physically tracing, and physically working with models in 3D, your brain is not going to be as fully wired as it could be if you simply interact in the digital world by typing on keyboards, clicking on mouses, and tapping on screens. So the use of technology is changing the way your brain is wired. And in many ways, it's changing in a detrimental nature. All of that is footnoted, key thought number two. Key thought number three, super, super, super important. You've never heard this before. It is very critical you understand this. And once again, you can look this up in the book called Into the Shallows. Screen reading, reading on a screen is different than reading physically in a textbook, a note card, or on paper. When our eyeballs hit a screen, whether it's our iPad or computer screens, our eyeballs tend to go in what's called hypertext skimming. We just kind of skim the page. Nobody reads Wikipedia word for word. We tend to skim, and we don't even realize it. We are not reading it for detail when our eyeballs hit a screen. But when we read on paper, we tend to be a little bit more detailed, and in textbook, line by line, reading word for word. Notice the finger on the paper. Screen reading is different than print reading. Again, footnote. And the last key thought is that if you increase the use of processing information through your fingers physically by writing stuff out, by using models, by tracing, underlining, shading, drawing, again, all of this is physically working with your fingers on diagrams, then it's going to improve how your brain processes and comprehends information. The more you increase this, the more you increase this. Once again, there's the footnotes. Let me summarize these key thoughts because this may be terrifyingly new to all of you. First key thought is simply that your fingertips are connected to your frontal cortex. Key thought number two, the use of technology is reshaping how brains and the neurons in the brains interconnect, and in many ways to a detrimental effect. Number three, Reading from a computer screen of any kind is different than reading in physical print, whether it's a physical note card, paper, book, etc. And key thought number 4, increasing processing information through your hands increases your brain function and processing. Now this sounds almost like science fiction, but trust me, I have years and years of experience. So I'm going to teach you a process on how to attack problem solving that reflects these key thoughts. And one of the main things students get frustrated is when you see something difficult and you don't get it, then you simply quit. You're like, I don't get it. And then there's this big fat stop. You stop thinking. Or not only stop thinking, you stop attempting. And in your brains, well, it's like, if I don't get it, how can I still give effort and not quit? If I don't understand something, how can I still give effort and not quit? And what I want you to really, really understand is that you don't understand first and then give effort. You get that? You don't understand a problem first and then you give effort, not effect. Let me write that properly. Effort. Instead, you put effort in first and then you understand. That may seem very foreign to you. You're like, how can I give effort if I don't understand? That's what this page is for. How things you can do even when you don't know what to do. One of the first things is you're going to learn to read with 3 body parts. You read finger on the paper with your eyeballs and your lips moving. Then you filter. Draw a label list, cross out. You're going to process information through your fingertips by tracing and sweeping things, tracing and marking things, tracing and stretching things, shading, finger blocking. You're going to hear this phrase in my class called squeeze the sponge. That means get out all the info that you know about something, even if you don't understand what to do with it. You squeeze out all the related information. And then you ask yourself, what can you do, not what should you do? Be very careful. The minute your brain asks the should question and you don't know what you should do, you stop. That should do question paralyzes most students. In other words, you ask yourself, well, what can I do? When you use equations, I want you to always put an equal sign. And equations have 2 sides with an equal sign. This will make sense as we do a problem. As you use equations, I want you to use the process called circle, plug, chug. I want you to physically box and label your answers. Then you go back and you just ask yourself, does this make sense? Once again, look at this page. This is on the front of your reference book. What you can do when you don't know what to do. So when you don't know what to do, here's 10 things you still can do. You ask yourself, did you finger track and read out loud? Did you underline keywords and numbers? Did you try to draw a diagram, label a diagram, list given information? You should have no naked diagrams. That symbol means your diagrams should have markings and labelings on them. That's what I mean by no naked diagrams. Did you trace and sweep angles, trace and stretch lines, trace all aspects of the diagram? Notice the repetition of the word trace, trace, trace. That means, did you process the information through your fingertips? Did you recite or say aloud what you learned in today's lesson or in the video? You don't know what to do? Did you skim through your reference booklet? Did you write out all potential equations with an equal sign, two sides? Did you solve using circle, plug, chug? Did you stop and try to actually visualize the information? Let's think about it. And last and most important, you need to understand, you apply effort first and then you understand. Effort yields understanding. You don't first understand and then apply effort. The effort comes before the understanding. Just stop and take a deep breath. You might be a little overwhelmed at the moment, so just pause, take a deep breath. Take another deep breath with me. Let's try this together. I'm going to read this out loud. Just read it. Just listen. Mr. Fareed wants to create a rectangular cement patio in his backyard along the side of his house. The length of the backyard is 8 feet longer than the width. Each bag of cement costs $6.50 and will cover approximately 12.5 feet squared. The perimeter of the backyard is 64 feet. Tax on the subtotal is 10%. Find the total cost of the cement backyard. Now, as I read this, I'd like you to simply rate it. Your very first gut reaction as I read it was your very first thought of, number one, wow, this is super easy. Or was it 3? Yeah, kind of average. Or as I read this, were you getting like goosebumps on your arms and you're getting intimidated, like, I am dying here? Okay, so as I read this problem, what was your first gut reaction? You're not going to be graded one way or the other. Just circle which one of those emojis represent your emotions at this moment. Okay, I've got good news for those of you who were somewhere on this end of the spectrum. You look at this and you're just like, I read it and it sounds like blah, 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 blah to you. Good news is I'm going to show you how to go from, oh, this feels so difficult. We're going to move you over here to this end using techniques that I call brain in hand. Ready to follow along? Okay, but before we do, we need to review a couple concepts from your prior math classes. The first concept is the difference between perimeter and area. So think of a fenced-in yard. You have a fenced-in yard. Perimeter would be the picket fence itself. The picket fence would be the actual fence. So perimeter, I'd like you to trace. Ready? Walk your pencil around. Notice, trace it around. Physically trace. Go all the way around. Put a little arrow there to represent walking around. Let's label length and width. And to find perimeter, all you do is you simply add up the lengths. So length plus width plus length plus width. Or you can write it this way. 2 lengths plus 2 widths, and that's true if it's a rectangle. So perimeter, think picket fence. You walk it around, physically walk it around. Area. I'd like you to shade this rectangle here. Just shade it, shade it. Area is like the grass or the sod. And if we have length and width here, this was a rectangle. To find the area, you simply do length times width. You need to be familiar with both of those. Perimeter, you simply walk it around, adding and up the length and the width. Area, its length times the width. Perimeter is an addition concept. Let's put a little plus sign there. And area is a multiplication concept. Okay, ready. Brain and hand techniques. The first and most important thing is that you read with 3 body parts. 1, you're going to read with your finger on the paper. That keeps your eyeballs from skimming like people tend to do who are digital natives. With your finger on the paper and with your eyeballs tracking with your finger and with your mouth reading out loud. That's step 1. So put your finger right there. I'm going to highlight, but your finger should be on the paper. Ready? We're going to read with 3 body parts. Your finger on the paper, your eyeballs tracking, and your lips reading out loud. So read out loud with me with your finger tracking with my highlighter. It says, Mr. Fareed wants to create a rectangular cement patio in his backyard along the side of his house. The length of the backyard is 8 feet longer than the width. Each bag of cement costs $6.50 and covered 12.5 feet square. Perimeter of the backyard is 64 feet. Tax on the subtotal is 10%. Find the total cost. Step 1 is to filter. Filter. Filter means to underline or highlight key words. So you read with 3 body parts and then you filter. So the words that we're filtering says, Reed wants to create a rectangular cement backyard on the side of the house. The length of the backyard is 8 feet longer than the width. Each bag costs $6.50 and cover 12.5 feet square. Perimeter of the backyard is 64 feet. Tax 10%. The ultimate question is cost. I always like to box that and put a question mark. Okay, that's called filtering. That helps your brain take what looks like a lot of sentences, and now you've cut down to the information almost half just by filtering. Now, you do these 4 steps all at the same time. You draw a diagram. Draw, label, list, cross out. Draw, label, list, cross out. Draw, label, list, cross out. You draw a diagram, label your diagram. Something that doesn't belong in the diagram, you list it and you cross it out. So ready? We're going to put our diagram on this side. And if it doesn't belong in the diagram, we're going to put it on the list. First, we have a cement backyard. So, and it's rectangular. So we draw a rectangle. See that? We cross it out. We took care of that. The length, like the word L, is an equal sign, 8 feet longer than, that's not 8 times as long, but 8 longer than, so that's a plus concept, the width. So we write that down on the diagram. The length is an equal sign, 8 feet longer than the width. I would label both sides. Length is 8 feet longer than the width, and then the width we just label. You ready? We accounted for that information. We cross it out. Draw, label, list, cross out. Each bag of cement, so we have bags of cement. I'm going to draw a little, like a bag here of cement. And we know 2 things about that cement. One, it costs $6.50 per bag. and it covers a total of 12.5 feet squared. So when you pour the cement, it's going to cover 12.5 feet squared. Cross it out, cross it out, cross it out. The perimeter of the backyard is, that's an equal sign, 64 feet. So I go like this. Ready? Put your pencil there. Always physically trace perimeter. Physically trace, physically trace, physically trace the perimeter. So trace it like this. We walk it around. Little arrow to represent going around, and I'm going to write underneath perimeter, capital P, equals 64 feet. When I walk it around, there. Tax. That really doesn't belong in the diagram. I just write over here, tax is 10% in addition to, and I focus what is the total cost, etc. Okay. So all of this, all these words just got boiled down to a diagram and a list. So you filter, draw, label, list, cross out. Okay, now we ask ourselves, not what you should do. Remember, the ultimate goal is cost. I'm just going to write the word cost way down here. Cost, question mark. Do not answer that question. What should I do to figure out the cost? Let's look at what you can do. Always start with what you know, and then you squeeze out the information. We know that the perimeter equals 64 feet. Well, what else do we know? We know the perimeter equals length plus width plus length plus width, right? That's just a general concept, length plus width plus length plus width. That's perimeter. What could we do with that? Right now, we really can't solve for a variable. So you ask yourself, what can I do? Well, if perimeter is 64, circle that, draw a little arrow. We could replace the P there with 64 equals, and we have a value for length in terms of the width. So for every length, I'm going to replace it with, the length is 8 plus W. You see what I just did there? Plus W, plus the length is 8 plus W, plus W. Why is that helpful? Well, look, now we're down to one variable. Now we simply collect like terms. We have 64 equals, I'm going to select my 8s. I have 16 plus, and I circle my W's. I have 4W. Equations have two sides with an equal sign. That's why I wrote my equations perimeter equals. You always write equations with two sides and an equal sign between those sides. You solve here. And we just figured out that the W equals 12 feet. Excellent. So you ask yourself, what else can you now solve? What can I do? Not should do. We just figured out W is 12. So now we can easily find the length, because the length is 8 plus W. So it's 8 plus 12. So now we just figured out our length is 20. So up here, our diagram, we just figured out the length of the backyard is 12 feet, and the width is 20 feet. What can I do? What can I do? Well, I just figured out the length and the width. We're dealing with cement. So cement, I know, is an area concept, we're not talking about fences here. So I could easily find area. And we write area equals length times width. Area equals 12 times 20. No, you're not going to touch a calculator. Why? Because you can easily do 12 times 2, which is 24. Then we just add the 0. So the area of the backyard is 240 feet squared. Now our ultimate goal is cost. So we look, what's going to start getting us money? We need to talk about bags of cement. That's money. And each bag covers about 12.5 square feet. So for every 12.5 feet squared, I need 1 bag of cement. So I'm going to go down here and I'm going to divide by 12.5 to figure out how many bags of cement I need. It says 19.2 bags, but be very careful. You don't buy 19.2 bags at Home Depot or Orchard Supply. So we're going to be purchasing 20 bags at $6.50 each. So 6 times 20 is 120. And then half of that So 20 times 650 is approximately $130. I don't think I got my decimal in there. Hang on just a second. Yeah, 130. I did get my decimal in there. So the process we used was this. We asked ourselves, what can we do? Equations have 2 sides. We circle plug chug. We plug stuff in. We boxed and labeled our final answers. And then we go back and we check and ask ourselves, does this work? So I'd like you to use this process for this problem here. You're going to do it completely on your own. Take you about 5 to 7 minutes. And then you're going to check your work. Now, as you do this, I want you to first, you read with 3 body parts. Finger on the paper, eyeballs tracking, your lips moving. Then you go back and you filter. Do this next step in 1 step. Draw, label, list, cross out. Physically trace stuff out, shade stuff, label it. Ask yourself, what can I do, not what should I do? If you use equations using 2 sides with an equal sign. Circle, plug, chug, box and label your answers and ask yourself, does this answer make sense? Do this on your own. Pause. Welcome back. So first we're going to filter here. It says Mr. Miss Johnson wants to plant a flower marigold border around the herb garden. The herb garden is rectangular, and the length of the garden is 3 times longer than the width. Every time you see the word is, that's an equal sign. The area of the garden is 108 feet square. It will take 2 pots of flowers per foot to create the border around the garden. The flowers cost $3 per pot. How much will it cost the ultimate question, box it with the question. The marigold border around the herb garden. That's filter. Check. Now we draw a label list, cross out. So everything goes on a diagram. It doesn't belong in the diagram, it goes on a list, one step at a time. Do not be overwhelmed here. Just do one little step, diagram. Well, I know it's a rectangle, so I'm going to draw a rectangle. I'm going to be trying to find a border around it. So I draw an arrow. At some point, I'm going to be looking for a border. The length is 3 times longer than the width. So that's 3 times longer, so I have 3W. So length is 3 times longer than the width. And that's the width, that's the width. I took these as an equal sign. The area of the garden, area, so that'd be like the shaded, I write area, you write area equals, is 60, not 64 this time, that was the last problem, 108 feet squared. Is the sign. It will take 2 pots of flowers per linear foot. So for every foot around the garden, for every 1 foot, I need 2 pots of flowers. So I draw a little diagram, 2 pots of flowers for every linear foot to create a border. And each pot costs $3. Ultimate goal is cost. Again, like most things in life, it always comes down to cost. Okay, we did draw, label, list, cross out. Many of you are like, I have no clue where to start, don't even know where to go. But you start by writing down what you can do. Really simple, can do. It is super easy to write out related equations. For example, we're talking about area here. Wouldn't it be super easy just to write out the area equation? That's easy. You can do that. Why do I do that? Well, I have information about the area, so I write out the area equation. I can write that down. Let's underneath. Let's write down what we know about the area. Area equals 108 feet squared. Now we can do what's called circle, plug, chug. We put things together that belong together. For example, see that area right there? Circle, see that area? We can take area and we can replace it with 108. So I write 108 equals, let's see if we can replace anything else. See length? Come over here. Can I replace length with something? I can. The length is 3 times the width. So circle length, plug it in. I'm going to write 3W. Then I circle this W and I write it down. Notice I'm circling so I keep track of what's going on. Let me zoom in here. So we're going to solve here. Now in the margin, I'd like you to write this down because this is very confusing to some students. I'd like you to, in the margin, write W plus W, W times W. W plus W means I have 2 W's. W times W is W squared. There is a difference. Please write that in the margin if you got stuck here. There is a difference between 2W and W squared. So right here, W times W, W squared. So I write 108 equals 3W squared. We're going to solve. Let's do that by dividing by 3. And 108 by 3. $36. So I have right here, I have 36 equals W squared. Now the opposite of squaring is square rooting, not divide by 2. So I square root both sides. That cancels. So I just found that my width of this diagram is 6. That's easy. I just found the width. You know, you ask yourself, what else can you find? If you just found the width, you can easily find the length, which is 3 times the width. So we just figured out that the length is 18. So let's recap what we know so far. We know that this edge is 6 feet, this edge is 6 feet, this edge is 18 feet, and this edge is 18 feet. Again, our ultimate goal is cost. So if something costs, you have to buy something, and we have to buy flowers. And for every 1 foot, we need 2 pots of flowers. So we need to figure out how many feet around is. Because it's a border. Put your pencil there. We're going to add. Trace with me. 6 plus 8 plus 6 plus 8. 18. 6 plus 18 is 24. 6 plus 18 is 24. 24 times 2 is 48 feet. So our perimeter, or our border, is 48 feet. For every 1 foot, we need 2 flower pots. So for every 48 feet, we need 2 flower pots. So we must purchase 2 times 48, 96 flowers. And now we have the number we're purchasing. They cost $3 each. So 96 times 3. I want you to get in the habit, if it's single-digit multiplication, try to avoid using calculator. It's good for the brain. It's good for the brain to do your multiplication by hand. 3 times this, 18, carry the 1. That's 27, 28. Total cost, $288. This seems overwhelming at the moment. You'll get better at this. Take a moment and reflect on the meaning of this page.